Hello and welcome back to this series of videos for my Logic and Philosophy class HUP 112. My name is Dr. Richard Brown, and today we will be talking about deduction, induction, validity, truth, soundness, strength, and cogency. That's quite a bit, but this is all coming from our textbook again, Logic, the Essentials. We're still working our way through Chapter 1 at this point, and in this video I'll be going over the exercises from sections 1.3 and 1.4 in the textbook. And as usual, what I'm going to be doing is just going over the exercises which have the answers in the book. Okay, so let's go ahead and start with the first set of exercises. This comes from section 1.3, as I said before, and what we're given is some arguments, and then what we're asked to do is to determine whether or not the arguments are deductive or inductive, and then if we can spot the kind of argument that we're dealing with. That's also very welcome as well. So here's the first example. Because triangle A is congruent with triangle B, and triangle A is isosceles, it follows that triangle B is isosceles. Okay, so we look at this. First of all, you have to know what congruent means. So if you don't remember geometry, for a triangle or other plane figure to be congruent with another one means that basically you can overlap them and they are the same. So it's another way of, a fancy way of saying that these two triangles are the same. They overlap each other. So therefore, you can see that this is a deductive argument. The conclusion follows with necessity. If the premises are true, then the conclusion must be true. In fact, this is what the book calls an argument based on mathematics. So you can just see automatically that it's talking about geometry, that's mathematics, so the conclusion is thought to follow with necessity. Now, some people may think, well, look, since this is sort of comparing two triangles, isn't this an argument from analogy or something like that? And that may be tempting, but it's technically wrong in this case, because arguments from analogy never give you the kind of certainty that this kind of argument does. So if thing A is somewhat like thing B in some respect, and therefore you can draw an analogy between the two things, it doesn't follow necessarily. It's contingent on those things actually being that way. That's an inductive argument. So this is a deductive argument, and don't want to confuse those sorts of things. If your spidey senses are tingling and you think, okay, this seems like an analogy to me, ask yourself the question, could it be the case that the premises are true and the conclusion is false? And just to make that clear, we can put this argument in standard form. The premise 1 is that triangle A is congruent with triangle B. Premise 2 is that triangle A is an isosceles. And then we represent that the conclusion with our line right there, and then the conclusion underneath triangle B is isosceles. Now this is putting the argument into standard form. So now it's much easier, I think, to see, if it wasn't before, that if those two premises are true, premise 1 and premise 2, then and given what congruent means, then the conclusion just must be true. Okay, so that's how you determine whether something is deductive, by asking yourself that kind of question. So here's another example from the textbook. It says no email messages are eloquent creations. Okay, some love letters are eloquent creations, therefore some love letters are not email messages. So we think about this. We see that there's the word therefore there, so the conclusion is that some love letters are not email messages. And this is something we'll talk about in the upcoming sections, but you should spot this right off the bat. This is a deductive argument, and in particular, it's a categorical syllogism. So categorical syllogisms are syllogisms, and syllogisms are arguments that have two premises and one conclusion, and they're categorical in nature because all of the propositions in this argument are categorical propositions. So categorical propositions are the ones that say no, all, some, or some are not. So the first premise here says that no email messages are eloquent creations. That's a categorical proposition making a claim about every member of the category of things which are email messages, and saying that none of them are in the category of things that are eloquent creations. We have the second premise It says some love letters are eloquent creations. So this is also a categorical statement making a claim about the group of love letters, saying that some of those things are also in the category of things which are eloquent creations. And then we have our conclusion, therefore, some love letters are not email messages. So this is a categorical syllogism, and therefore all categorical syllogisms are deductive. So this is a deductive argument. Now, in the next section, we're going to start asking, how do we know whether a deductive argument is good or bad, valid or invalid? But right now, we're just trying to identify when it is that a deductive argument is present, because that's what we're going to be really focusing on in the rest of this class. Excuse me. Okay, so let's take another example here. Paying off terrorists in exchange for hostages is not a wise policy, since such action will only lead them to take more hostages in the future. Okay, so this is an argument because we see the word since right there, which is indicating that there's a premise. Paying off terrorists will only lead terrorists to take more hostages in the future. Therefore, paying off terrorists in exchange for hostages is not a wise policy. So is this a deductive or inductive argument? Well, you have to ask yourself the question, could the premises be true and the conclusion still turn out to be false? So in other words, could it be true that if you pay terrorists in exchange for hostages, then that will only lead them to take more hostages, and yet somehow false that it is not a wise policy? Well, I hope you can see that that is possible. It may not be actually true. You could debate that, but it certainly is possible that the premise is true and the conclusion is false, and making this an inductive argument. This is specifically a kind of causal inference, saying that one event causes another is always an inductive inference. And so you could spot that right off the bat, but also, just as we were saying, the conclusion only probably follows from the premise. So given that the premise is true, then the conclusion is likely to be true, but it's not necessarily true. So these kinds of inferences are always inductive. Let's take another example. And of course, we could put that in the standard form, but we won't, because I will only be focusing on deductive arguments. This class is about deductive arguments. And so whenever I spot an inductive argument, I'm sort of going to set it aside. Okay, so here's another example. The Wall Street Journal has an article on the new banking regulations. The Financial Times, like the Wall Street Journal, is a highly respected business publication. Okay. Therefore, the Financial Times probably also has an article on the new banking regulations. Okay, so hopefully you can see that this is an inductive argument. You see the word probably right there in the conclusion. Therefore, the Financial Times probably has an article. Now, it's not always the case that people use these words correctly. So sometimes people throw out the word probably when they don't really mean it, or when it's not justified by what they've actually said, when the inference is stronger. But that's an indicator that's probably this is an inductive argument. And in fact, it's pretty clear this is an argument from an analogy. So what's going on here is that the person is saying these two journals are similar because they're both business publications that are respected. And so since one of them has this article, probably the other one will. That's clearly saying, well, since they're similar in this respect, and one did one thing, then the other will do that thing as well. So that's an argument from analogy. And arguments from analogy are always inductive, as I was saying previously. And that's just because it's possible for the premises to be true and the conclusion to be false. Now, of course, these arguments can still be better or worse inductive arguments, but they don't rise up to the standard that deductive arguments meet. Okay, so let's take another example here. World-renowned physicist Stephen Hawking says that the condition of the universe at the instant of the Big Bang was more highly ordered than it is today. Yes, low entropy. In view of Hawking's stature in the scientific community, we should conclude that this description of the universe is correct. Okay, so it's pretty clear, I think, that sentence right there. Remember, I don't write these examples. These examples come from the textbook. I have no control over them. I just use them. I think they're Some of them are good examples, but this one's pretty pretty silly maybe, but it's pretty clear that what the person is saying there, in view of Hawking's stature in the scientific community, it's pretty clear that that's an appeal to authority. So they're saying because this guy's so well respected, he's probably correct. But of course, that's um, some people might say a fallacy in an inductive reasoning class, but we're not going to um, delve into the intricacies of inductive reasoning. But it's pretty clear that, just because this guy's well respected, it doesn't guarantee that the view that he has is correct. Okay, so here's another example. When the Romans occupied England, coal was burned. Okay, since coal produces quite a bit of soot and sulfur dioxide, there must have been days almost 2,000 years ago when the air in the larger towns was badly polluted. Ah, interesting. Okay, so now we clearly see an argument here. So when the Romans occupied England, coal was burned. That's a premise. Since coal produces quite a bit of soot and sulfur dioxide, um, there must have been days almost 2,000 years ago when the air in the larger towns was badly polluted. That's the conclusion, and those two first things are the premises. Now, clearly, there's some kind of inductive inference going on here, and it seems to me that this is a causal inference. That what the person is doing here is saying, well, since burning these things causes this other thing, the production of soot and sulfur dioxide, then since they did this back then, it would have caused the same results. Now, of course, that's always cause and effect reasoning is always inductive, and this is something which you could, from your intro to philosophy class, may have read about or heard about, or if you've taken a philosophy of science class, may have studied it quite carefully. But it's typically thought that these kinds of inferences are all inductive based on previous experience with the world, which is not guaranteed to yield the same result. I guess Kant didn't have as much of an effect as he would have liked. Okay, but at any rate, this is an inductive argument because it certainly is the case that whatever you think about cause and effect, that the premises can be true and the conclusion could be false. So it could be true that the Romans occupied England, they burned coal. It could be true that coal produces quite a bit of soot and sulfur dioxide, but it might be false that 2,000 years ago the air in larger towns was badly polluted, because who knows, the Romans may have been very good at clearing out that stuff. So it's not guaranteed or known with necessity. Okay, so let's take another example. Here we go. So each element, such as hydrogen and iron, has a set of gaps, wavelengths that it absorbs rather than radiates. So if those wavelengths are missing from the spectrum, you know that the element is present in the star you are observing. So this is taken from the book Eyes of Science here, and the premise, each element, such as hydrogen and iron, has a set of gaps, wavelengths that it absorbs rather than radiates. The conclusion, if those wavelengths are missing from the spectrum, you know that the element is present in the star you are observing. So if the premise is true, then the conclusion follows necessarily. And so this is a deductive argument. You may think, well, look, isn't this an argument sort of scientifically based on induction? And well, the first premise may have been inductively garnered. We may have inductively learned that each element, such as hydrogen and iron, has a set of gaps, wavelengths that it absorbs rather than radiates. But once you accept that as true, then the conclusion follows necessarily. And so in science in general, we find both deductive and inductive arguments employed. And often what will happen, and this is a point that Aristotle made a long time ago, but it still generally is the case, I think, that when you are trying to discover the laws, like laws of physics and so forth and so on, or laws of chemistry, whatever it is, when you're trying to discover those laws, you're doing a lot of induction. You're doing a lot of observation, trying to distill out the laws. Once you have what you think is the correct law-like description of stuff going on here, then you can deduce the way things will behave. And so while physicists will discover the laws like the Newton's laws of mechanics inductively. Certainly Newton discovered that stuff inductively. But then once those equations are written down, we can deduce the way various systems will behave. And so when you apply a law to a physical system, then you're engaging in deduction. That sort of seems what's going on here. We have something that we may have discovered inductively, but now we're applying it, and that is deductive. Now, of course, if we wanted to write this in standard form, we would do what I was just saying earlier. There's the premise is that each element has a wavelength which it absorbs rather than radiates, and the conclusion is that if those wavelengths are missing from the spectrum, you know that the element is present in the star you are observing. The word observing seems to have mysteriously disappeared from my conclusion, but that is supposed to be there. Okay, so let's continue doing examples. Lenses function by refracting light at their surfaces. Consequently, their action depends not only on the shape of the lens's surface, but also on the indices of refraction of the lens's material and the surrounding medium. All right, so that's from physics there. And this is clearly a deductive argument. Hopefully, you agree that it's necessarily the case that if those premises are true, then the action of lenses depends not only on the shape of the lenses, but also on the indices of refraction of the lenses and the surrounding medium. But as I say in this sort of parenthetical remarks, which again are just taken from the books, as I said right there, this could also be interpreted as a argument from definition. So even if you didn't just want to think in terms of the premise and inclusion, and I'm not going to write this in standard form because I think it's starting to get, hopefully you're starting to get the point that writing an argument in standard form is taking the premises, putting a number in them, and then distinguishing the conclusion with some conventional method, which we have done. So let's just take another example. It's always nice to see a Sherlock Holmes example. So here's one. The Simpson incident had showed me that a dog was kept in the stables, and yet, though someone had been in and had fetched out a horse, he had not barked enough to arouse the two lads in the loft. I suppose he refers to the dog there. Obviously, the midnight visitor was someone whom the dog knew well. Okay, so this is Sherlock Holmes here. Making a kind of inference. What kind of inference? Well, it seems if you were to sort of look what was going on here, it seems like what's going on is that Sherlock is saying, well, dogs who are familiar with people will not bark at them. That's something that you learn from experience with dogs, perhaps, and so that's a kind of causal inference. There's a kind of cause and effect thing going on there. The dog's familiarity with the visitor caused the dog to be silent. Okay, so of course, that could be, it could be true that all of those things that Sherlock had said were the case, and yet false that the midnight visitor was someone who the dog knew well. You know, maybe the dog was drugged or something else was the case. But this is, if those premises are true, then the conclusion is likely to be true, and that makes this a strong inductive argument. Okay, so continuing with some examples here. From a cultural anthropology textbook. Animals that live on plant foods must eat large quantities of vegetation, and this consumes much of their time. Meat eaters, by contrast, have no need to eat so much or so often. Consequently, meat-eating hominins, which means early humans, may have had more leisure time available to explore and manipulate their environment. Like lions and leopards, they would have had time to spend laying around and playing, lying around and playing, I guess. Okay, so by now we should be getting good at this. This looks like clearly a cause and effect relationship, and there's also a kind of a clue here because the person who wrote this, William Haviland, seems to have used the word may, which indicates a kind of probable inference. So this is an inductive argument, and it's again a causal inference, kind of cause and effect. Okay, so it's not always the case that when you see the word may, that guarantees that the argument is an inductive one. People don't always use words correctly. So it is possible, actual, that people will use the word may when in fact there's a deductive argument. So you can't just scan and see the word may there and then say, aha, therefore this is an inductive argument. But the word may together with what's actually being said certainly could be true, that animals that live on plants must eat large quantities, and it could be true that this consumes a lot of their time and that meat eaters don't have to eat so much or so often. But it might be false that meat-eating early humans had more leisure time, because they could have been doing for various other reasons that may have been false. So this is a nice probable inference, but not necessarily guaranteed. Okay, so let's switch now to talking about validity and invalidity. So we were just in the previous section trying to distinguish between inductive and deductive arguments, and now what we want to do is focus on deductive arguments solely, and focus on the question whether they're good or bad. So for us, a deductive argument is valid, and a bad deductive argument is invalid. And we'll say more about how we really tell the difference between how we prove the difference between the two in the next section. But for now, what we want to do is just rely on the definition. A valid argument is one where it's impossible for the premises to be true and the conclusion to be false. So we need to think about excuse me, we need to think about the following arguments, put them in the standard form, and then ask the question whether it's possible for the premises to be true and the conclusion to be false or not. And everything that we're going to be given, at least for the next remaining part of the video, is going to be a deductive argument. So that much we can know already. So what about this one? Well, this argument here, which I prematurely jumped the gun on, is a valid argument, which happens to be unsound. So the premises here is that Moby Dick was written by Shakespeare. Thought I had a premise coming up here. Aha, there's my premise there. I'll get to that other stuff in a second. I'm sort of not doing the animations correctly, but I'll come back to that. So the first premise is that Moby Dick was written by Shakespeare. The second premise is that Moby Dick is a science fiction novel. And the conclusion that's drawn from that is that Shakespeare wrote a science fiction novel. So this is a valid argument. To call it valid is to say that if those premises were true, then the conclusion would have to be true. So it in fact is not the case that Moby Dick was written by Shakespeare. It's also not the case that Moby Dick is a science fiction novel. It's also false that Shakespeare wrote a science fiction novel. I say now I have a typo there. Should be wrote, not write. Obviously, Shakespeare wrote a science fiction novel or writes one. Okay, so, oh well. But at any rate, that conclusion is still false. So the premise is false, both of them are false, and the conclusion is false. But nonetheless, this argument is valid. It's valid because being valid, this is something that students really have a hard time at the beginning grasping. To call an argument valid doesn't mean that the premises really are true. It just means that if those premises were true, then the conclusion would also be true. And you can see here that that does seem to be the case. Suppose, just pretend for a second, that it were really true that Moby Dick was written by Shakespeare. And also that it was the case that Moby Dick was a science fiction novel. Then it would have to be the case that Shakespeare wrote a science fiction novel, because those premises guarantee that if they're true, the conclusion is also true. Now, in this case, the premises are false, the conclusion is false. The premises being false is enough for the argument to be unsound. Unsound arguments are valid arguments where the premises are false. So that's what's going on here. And you really, at this point, need to start paying attention to the distinction between an argument being valid, which means that if the premises were true, not that they are, but if they were, then the conclusion would also have to be true. And the argument being sound, which means that if the first thing is met, then the premises actually being true guarantees that the argument is sound. So that's what we really want. The gold standard is that we want a sound argument, one that's valid with true premises. But for reasons that will become clear as we move through the class, what we want to do before we start thinking about whether the premises are true is to figure out whether the arguments are valid or not, whether even if the premises were true, would it guarantee the truth of the conclusion. That's the central idea of deductive logic, that some transitions preserve truth. You start with something true and you end up with something true. Okay, so let's look at another argument here. The longest river in South America is the Amazon, and the Amazon flows through Brazil. Therefore, the longest river in South America flows through Brazil. Okay, so now the therefore indicating that the conclusion, the longest river in South America flows through Brazil. Premises, longest river in South America is the Amazon. Premise one. Premise two, the Amazon flows through Brazil. So this argument, if those premises were true, the conclusion would have to be true. So this argument is valid. Those premises, in fact, are true. You might have to use Google to determine that. I did, to be honest. But they are, in fact, true. The premises are true. The conclusion is true. This argument is valid and also sound. Now, I won't write it in standard form because I hope that you can by now see that I already sort of said what it was, premise one, premise two, and the conclusion. So I'll sort of skip that at this point. We'll come back out, always write things in standard form when they're necessary, especially when we start wanting to prove whether these things are valid or invalid without just relying on our intuition. Right now, we're just trying to, again, illustrate this idea that, just in case it's not clear, excuse me, we're trying to illustrate this idea that we already know how to reason. I'm not trying to teach you how to reason in this class. I'm trying to give you a theory about how reasoning works. And so we all have a kind of data set already about which argument patterns or reasoning patterns or inferences that we think are good and which ones we think are bad. We may not be infallible. So I'm not saying that we're perfectly rational. Some of these things we may not realize at first glance that they're valid or invalid. But once it's explained, hopefully, if you think about it long enough, you'll see, yeah, okay, that one is good, this one is bad. That's the basic data that the class is trying to theorize about. And that's why we want to spend some time before we even get into all the mechanics of the theory about what makes an argument valid or invalid. Just spending some time giving some examples. Okay, so here's an example. All leopards with lungs are carnivores. Therefore, all leopards are carnivores. Strange claim. This is an invalid argument. I hope you can see. It's true, in fact, that all leopards with lungs are carnivores. It's also true that all leopards are carnivores. Leopards will basically eat anything, from what I can tell. So why is this argument invalid? Well, we'll specifically talk about how to show the arguments are valid or invalid in later sections. In fact, a lot of the class is developing the ideas about how to prove validity or invalidity. But you can see that, well, okay, if this thing happens to be saying something true about leopards, because it is true that all leopards are carnivores. But what if you said that, all men with short legs are envious? I don't know. Yeah. Just off the top of my head. Therefore, all men are envious. Well, you can see that even if that first sentence is not literally true, even if it were true, it wouldn't follow that all men are envious just because all men with short legs are envious. So while it happens to be true that all leopards with lungs are carnivores, happens to be true that all leopards are carnivores, it's not guaranteed by what the structure of the inference is. It seems to be something that's dependent on something else, something that's not that's extra logical, beyond logic, and therefore that our inference is not valid. Okay, so let's take another example. Every province in Canada has exactly one city as its capital. Therefore, since there are 30 provinces in Canada, there are 30 provincial capitals. Okay, so the conclusion is that there are 30 provincial capitals in Canada, and this argument is valid. I hope you can see that if the premises were true, then the conclusion would be true. Turns out that it's unsound because there's false premise. So there's not 30 provinces in Canada. I'm pretty sure that's the one that's false. Okay, so, but if that premise were true, the conclusion would also be true. Now, just in case, I don't know why I did this. I just got through saying I wasn't going to do this anymore. But here I go doing it. So there's the argument in standard form. First premise, every province of Canada has exactly one city as its capital. Second premise, there are 30 provinces. Conclusion, 30 provincial capitals. Okay. Okay, so let's take another example here. So since some fruits are green and some fruits are apples, it follows that some fruits are green apples. Okay, so we can see that the conclusion is that it follows that. So some fruits are green apples is the conclusion. Some fruits are green, some fruits are apples. So this argument, the premises are true, conclusion is true. Nonetheless, this argument's invalid. It's invalid because while the premises in fact turn out to be true, and the conclusion turns out to be true, this reasoning, the pattern expressed by this kind of reasoning, the inference here, doesn't guarantee that to be the case. It's possible that the premises are true, and yet the conclusion to be false. So to make that clear, let's put the premises in their standard form. So 1, some fruits are green. Premise 2, some fruits are apples. Conclusion, some fruits are green apples. Okay, so now in the next section where we talk about counterexample methods, and then later in the class we'll develop more tools for trying to really get clear about this. But hopefully it's intuitively clear to you that this is an invalid inference, because you might say that you might say, I don't know, some cheese is round, some cheese is delicious, so therefore some cheese is round delicious. Well, it doesn't quite work there. So we can see there's some sense in which the premises can be true and the conclusion can be false. We'll develop this more in the next section, but that's an invalid argument. Okay, so since Tom is the brother of Agatha and Agatha is the mother of Raquel, it follows that Tom is the uncle of Raquel. So, wow, okay, that's just a definitional argument there, so that's clearly valid and deductive. If Tom is the brother of Agatha, so Agatha and Tom are brothers, and Agatha is the mother of Raquel, so Raquel's her daughter, then obviously that's her uncle. That's just what it means. So yes, that's deductive and valid. It's impossible for the premise to be true and the conclusion to be false. I won't write that one in standard form. Okay, so what about this one? Since Christmas is always on a Thursday, it follows that the day after Christmas is always a Friday. Okay, so that is a deductive argument, and in fact is valid. But it's not sound. So it's false that Christmas is always on a Thursday. But if it were true that Christmas was always on a Thursday, then it would also have to be true that the day after Christmas is always a Friday. That's just given the way the definition of the days. So that's given those definitions, this is the way things have to be. There's no wiggle room. So those are both deductive arguments. Let's do another example here. So after taking LSD, okay, Alice said she saw a flying saucer land in the shopping center parking lot. Since Alice has a reputation for always telling the truth, we must conclude that a flying saucer really did land there. Okay, there's a really strange argument there. Notice that the person uses the phrase "we must conclude," so that seems to indicate that whoever saying this or writing this thinks that they're giving a deductive argument, because that's what that phrase there indicates usually, a necessity. But clearly this is not a deductive argument. This is an inductive argument. So this is if the premises could be true. So it's true that Alice took LSD. It's true that Alice said she saw a flying saucer land in the parking lot. It's true that Alice has a reputation for always telling the truth. But it's false that a flying saucer really did land there, you could say. Now, of course, this is clearly, excuse me, this is clearly just taking someone's word for something and who's on LSD. And that indicates that even if the premises were true, there's not very much reason to believe that the conclusion will be true. So this is a weak inductive argument. Inductive arguments can be strong or weak. So the strong ones tell you that, yeah, if the premises are true, then probably the conclusion is true also, probably. But this one, premises could be true, and there's probably not the conclusion being true. So this is a very weak inductive argument. Okay, so let's take this example. Circle A has exactly twice the diameter of circle B. From this, we may conclude that circle A has exactly twice the area of circle B. Okay, so this is a deductive argument based on mathematics, but it's invalid. That's not the way area works. Twice the diameter doesn't mean twice the area. And so that's just the way that works. That's just a mathematical fact. So that's an invalid argument. Premise is true, conclusion false. Okay, so let's take one final example. This cash register drawer contains over 100 coins. 3 coins selected at random were found to have dates earlier than 1960. Therefore, probably all of the coins in the drawer have dates earlier than 1960. Okay, so therefore, probably indicates that this is an inductive argument. And although that's not guaranteed, it's not certainly known just because it says that. Reading the rest of this, it seems to verify what the word probably there says. This looks like some kind of statistical inference, and statistical inferences are always inductive. So this cash register contains over 100 coins. 3 of them selected at random have these early dates, so all of them do. That's very weak evidence. So this is an inductive argument, which is very weak. So 3 out of 100 doesn't give you a very strong basis to conclude that all of something have that. Okay, so just to one final example, since x plus y equals 10 and x equals 7, it follows that y equals 4. Okay, so obviously 7 plus 3 is 10, not 7 plus 4. So this is a deductively invalid argument. It's invalid because it's not true. The conclusion, it follows that y equals 4, is false, given the 2 premises over there being true. Okay, and then finally, statistics reveal that 86% of those who receive flu shots do not get the flu. Jack received a flu shot 1 month ago, therefore he should be immune even though the flu is going around. All right, so he should be immune. He is probably indicating that this is an inductive argument. Reading the rest of it, we see that this is an argument based on statistics, and I've already said statistics, those kinds of arguments are known to be inductive. So this is an inductive argument. Is it weak or strong? It's strong. It's strong because if the premises were true, then the conclusion would probably be true. So the premises are true. Statistics do reveal that. We'll assume that Jack received his flu shot 1 month ago, and therefore probably he should be immune, even though the flu is going around. It could be false. He may not be immune, but we have some reason to believe that that is the case. So this would be an inductive and a strong argument. Okay, so in the next video, we'll come back and talk about how we can actually show that deductive arguments are valid or invalid using the method of counterexamples, which I've hinted at in this video.